Okay, so today I wanted to go through a bit of Matlab with you. Okay, so I'm going to write some Matlab. I'm going to put that on Blackboard or wherever it's going to be, so you can redo the same. It's kind of trying to mirror what you have done in the lab and trying to give you a quick refresher on Matlab, ways about doing stuff. Okay, so. Usually when you start a script, okay, so it's a bit like in Python or anything like that, you have two ways of working. So either you work directly as a normal script and then just call your functions from here, or you have a file that contains all your functions, okay? So usually you have one file per function. So the file name dictates what this function does and what the name of the function is. So here we're just going to write a script and start from the basics. So usually we start by writing blocks, okay? So if you put percentages sign like this, what happens, you define a block, okay? Sorry, I'm just going to switch off the light here so you can see better. Yeah, maybe. So when you start a block like this, you have the background of the text of the block is highlighted in light yellow. Okay, I don't know if you can see that from where you're sitting, but basically, when I'm moving here, all the block is highlighted in yellow. And depending if you're on a Mac or PC, if you press something like Control Enter or Command Enter on Macs, basically you evaluate this particular cell. Okay, so if you're familiar with Jupyter with Python, this is the equivalent of a cell that you can execute and come back to. All right, so usually what you do is you say clear all, close all. Okay, and so the reason why you do that is because probably you've been doing stuff in your command window. And all the values you've done here will be saved. And so when you execute command here, it's just executing command based on what is already saved in the command window. Okay, so if you want to start a script from fresh, it's a good practice to start by saying, okay, clear all and close all the stuff. That will close all the windows and clear all the variables. All right, so just to make sure I'm doing the right stuff here. Right, so now I'm going to as well to clear. Then clear will clear the command window, I believe. No, it doesn't. That's fine. Right, so we are going to go to the same place we've been to. So here you can, CD to go to any kind of directory you want. And in this directory, I just saved a bunch of pictures and scripts. And in particular, I have the Lena 256 picture that you guys have to work with in the lab, okay? So what I'm going to do is I'm just going to first open that file like you would open any binary file, okay? So using fopen, so that's similar to C or anything doing. And then I'm just going to basically read that file as if it was an array of numbers, okay? In this case, it would be bytes, and I say this is an array of size 256 by 256. So a little point here. This little sign here, so the quote, single quote, it's transpose, okay? So it's matrix transposition, okay? So basically, what happens when you read this picture, and you've probably seen that in the lab already, when you read the picture directly, what happens, the picture looks like it's rotated by 90 degrees, okay? And that's because there is a discrepancy the way this file was saved and the way Matlab is reading it. So Matlab reads, so let's look at picture first, okay? So picture, this bunch of numbers. I always advise you to type whos, and whos gives you a list of everything you have saved in the command. Okay, so that is very useful. because not only you have the names of all the variables you're using, you have the size. Okay, so now we have fin. So fin was just a file input handler. It's just a handler for that file, so we don't have to worry about that. But if you look at picture, we see, okay, this is an array of size 256 by 256. Has a whole bunch of bytes, and it's of size double. Now, it's of size double because when you come back to the history of what we typed in, so that's a command, we read fread, and that would have read basically bytes, but I've applied double, so I transform these integers into double precision. So double is the default, like in Matlab, you rarely use floating point accuracy. You always use double, okay? And that's good practice to have. Right, so if you look at this picture, okay, so we can try to display that picture. There's different ways of doing that. I'm just going to show you one way, which is the imshow command. And so what happens here is you don't see anything, okay? And this typical problem you have is, can you tell me what happened here? Why do I see all white? I already mentioned that in the lab. Can something see why there's a bug here? Or if it's a bug. Right, so I've converted my integers to double. So now the values still are between 0 and 255, but now they are doubles, okay? So Matlab, as I said in the lab, by default will assume that we'll have two modes of operations if you want. Either you give it to all these kind of built-in functions, so such as imshow, you give it a picture of type uint8, in which case it will display it correctly, so between 0 and 255. Or if it's a floating point or double, then we'll assume that the range is between 0 and 1. Okay? So here the program have floating points whose values are almost all of them bigger than 1, and therefore all the pictures are saturated, no, the pixels are saturated and you display whites. So what you need to do here is something like that. You need to divide the picture by 255, so the range would be between 0 and 1. And still doesn't work. Right. So let's have a look at the picture's values. Okay, so sorry. Aha. No, this is what's going on. Sorry. I read the picture twice, so that's not going to work out very nicely. So let's do it again. All right. All right. Right. Okay. So what happened here is I forgot to close the file and tried to read it twice and just didn't give me error warning. So I'm just going to close that file. Sorry. Maybe F-close. All right. Okay. So now when you come back, I have this picture. Another way of displaying, so this is a grayscale picture, okay? Another way of displaying this kind of picture, so there's the image function. And if you do image, you have similar issues. And even if you do image divided by 255, you'll have an issue. And that's because here you have to say that actually you're looking at a grayscale map. Okay, so kind of image assumes you're working with color. So you have to do that. So let me just copy paste that guy. So what I'm doing here is I'm going to specify a color map. So just a way of saying how the colors are done and so on. And I'm just going to say that the values are between 0 and 255 this time in double. So it'll be all fine. And this is what I get. So image is slightly different. You have the axis and the aspect ratio is not necessarily preserved, so it will scale when you move it. Okay? If you want to inspect the picture, you have these zoom buttons, and you can come back on that and see the pixels. And this little guy with a plus is very useful allows you to do to look at, select any pixel, and it gets you exactly the values of the pixel you're looking at, which turns out to be quite useful in practice. Right. Okay. Another thing sometimes you do when you do ImShow is, let's say you have the range of the values is not between 0 and 1, or it's going to maybe all contracted between some values you're not so sure of. One nice way of dealing with that is to specify this optional command, so 0, comma, virgule, empty square brackets. And what that does basically is that, so in this case, we give very similar results. But what it does, it will find automatically what the minimum value, maximum value, and rescale all your data between 0 and 1 according to that. So 0 would be the minimum value of your picture, and 1 would be the maximum value of your picture. So if you don't know too much about the range of your values and so on, by default, you can just try this command and just work out fine. Right, so let me sure I'm doing the right stuff. Yes. So a bit of word of caution on all that, okay? So there is, Matlab is a bit odd when it comes to arithmetic, okay? And I just want to make sure that you understand that. So let's say I have a unit 8 number, okay? So here I've got, so by default I say all the numbers are double. So if you type 6 in Matlab, actually this is a double, okay? So by default it will treat that as a double. So any number you typed in will be by default a double. But if you, in this case, I really specify, say, okay, this is of type unit 8, and so unsigned car. And so when you look at all the variables I have, you have A here, it's just a scalar, okay, so 1 by 1, and it's 1 byte, and it's class unit 8. That's all fine. So here's the problem, okay? So if you do, so if you say B, so if you do arithmetic like this, it kind of makes sense. You multiply by 2, you still get a unit 8. It's all fine. But here's the problem, okay? So A is 100, and the maximum value we can have is 255. So let's add just a big number here, okay? Let's add 200, okay? So we have A is 100, and we add 200, okay? And this is what we get, okay? We get 255. Now in C, you would expect that to kind of roll back and give you, when you have an overflow, it will come back it will start at 0, okay? So in C, if you have something like that, so 256 is just one unit higher than the highest possible value. So in C, you would expect that to be 0. All right? So if you type that in C, that would be 0. But in Matlab, it's 255. Okay? So in Matlab, you don't roll back to the original values, you actually clamp it. And this is true of negative values as well. So if you have, if you cast a negative value, then it will clamp to 0. All right? Similar weirdities as well. If you have 100 divided by 120, so in C again, this is actually less than 1. So 120 is bigger than 100. So when you do that, you expect to see 0. All right? Sorry. But in Matlab, it's 1. So it rounds to the nearest integer. Okay? Bottom line, don't end up working with unit 8. Okay? It's just, that's going to confuse you. It seems to be like nice behavior, but then you'll be confused by what's going on. Okay? So just work in doubles. Right, so that was it. Okay, so let's see how. So this is something quite nice with Matlab, is the way it deals with everything as being matrices, okay? So let's have let's define a matrix, okay? So here we're going to create a 2x3 matrix. So that's matrix A, all right? So that's how you specify it. You just put your square brackets. And you have the choice, okay, either you put spaces, or if you want to be explicit, you can put a comma here. It's up to you. Semicolon means you go to the next line, okay? Right, so that's your matrix. In Matlab, it's important to understand that they do store these values in a row by column order. And by that I mean if I try to access each of the elements one by one, so if I access, A of 1, okay, I just want to know what the first element of that, this would be 1, okay? If I access the second element, okay, this is 4, right? Because the matrix is stored. Matlab will try to look at this value, start this value first, and then in the next in the memory will be 4, and whatever comes next along these the rows, and then we'll move on to the next column. All right. So something to keep in mind: the first order of preference is the first dimension. Okay. So similarly, if you have plenty of dimensions, you'll still start with the first dimension, and so the elements in your first dimensions are always contiguous in memory. So you can do quite a lot of things with the columns operator. The first thing you want to do is usually apply quite a lot is this command here. So you have the matrix, you can just say round brackets of columns, and what you get is a flattened version of your data. Okay, so it kind of gives you just a single vector with all your data, as all your data is stored in memory. Okay, so you had potentially a multidimensional array, so A, and now what you get back is something of dimension 1, really. So the same way the whos commands help you to know how everything was stored. So let's do that again. So type whos, and now you have this A matrix, and it says 2 by 3. So remember, 2, it's the first dimension, so the number of rows you have. This is similar to what you have in mathematics. Okay, so Matlab is defined according to math notations. So 2 is the number of rows you have, and 3 is the number of columns. Right. Now you could find that out directly by typing size of A. So size of A returns you an array of 2 elements, and the first one is the number of elements you have in the first dimension. The second one is the number of elements you have in the third dimension, and so on. Okay, that's a way for you to be able to access this in a program. You can actually get the values directly in your program. Now, let's see the command I just typed before, which is the way of flattening all that. Now, A is now 6 by 1, okay? So type A again, just to, okay? So basically what it says, like, when I'm typing this, I create a new matrix of dimension 6 by 1. So 6 is the number of elements in A, and they're all on the first column, and 1 is the number of columns you have, and you just have 1, okay? So Matlab will always at least display you 2 dimensions, okay? So if you just have a scalar or a vector, you would just say something by 1, okay? Just to tell you that it's only a vector. All right, but you can do cool stuff, okay? So if you want to access the first row, okay? So I'll just type A again. So let's say I want to access the first row of your matrix. The way I would go about doing that is to say, right, I'm looking for the first row, so that's 1 here, and then I want all the elements along that row. All right, and that will give you this horizontal vector, which all the elements. side note here, if you look at the size of that, Matlab kind of preserves the shape of it, of what you gave to it. So it would say now it's a size, it's a row vector, so the number of rows is only 1, but the number of columns in that row is 3. Okay, it's, slightly different from what you had before. Similarly, you can access the first column of that vector, and because you're looking for a column, you're looking at all the elements along the first dimension, and let's say we're looking at the second, the middle column, and this is what we get. Okay, so again, this was A, and that's fine. Okay, and this time, the size of this vector is so this guy is this time a column vector. So we have 2 elements in that column vector, and only one column and 2 elements in that column. All right, so these are kind of very powerful ways of accessing and taking submatrices from your part and so on. If you come back to the picture we have, okay, I'm just going to show you that quickly. So let's do that again. All right, so first I'm going to close all the elements in my picture, and I can display that again. So this is my picture. But you could crop that picture, okay? So let's say you have a region of interest, and so I'm going to access a range of in the y and the x coordinates. So I'm going to look at that doesn't matter really. Okay. All right, so what is happening here is that I'm going to crop that picture by accessing the array with this kind of shorthand, which is very similar to what I've done here. So here I've extracted all the elements in the column, but here I'm saying, right, I'm going to only focus on the range 100 to 120 inclusive, okay, in the rows of picks, and look at the range of 200 to 240 inclusive in the columns of picks. And basically, what this does is it will extract for you something very small here. Okay, you just cropped that picture. Now I'm going to use image because it's a tiny bit easier to control, to show you that again, because imagery scales nicely. Right? Show that again to you. So here we just cropped an image, and the image is 21 in height and 41 in width. Okay, it's just a block in your picture. Let's show you that again. Okay, so we have A. Let's make A a tiny bit bigger. All right, so that's A, and let's say I want to take the last quadrant here. So I could say take all the coordinates from 2 to 3 in the y-axis on the first dimension, and all the coordinates from 2 to 3 in the x-axis, and then what you get is only this sub-block. Okay? And you can combine that. Okay, you could have just said, but take only the two first, these 2 rows and all the columns, in which case you get something like that. Okay. Right, so where are we at? Is that clear? Any questions on that? It's fairly boring, but you have that, all the all the stuff in the, I put that on Blackboard, and so you'll be able to kind of, I see that as kind of like essentials, it's a kind of a way for you to go back to if you get lost. Right, so let's look at histograms and something you've seen, okay? Let's clear all and close all. And let's load this picture, okay? So, again, who's, by default, I've loaded something in Unit 8, which is usually typically what happens. Sometimes, though, pictures, depending on how they're saved, and sometimes people, depends, file format could accept floating point or could accept 16-bit accuracy. Anyway, so you have to be careful. It's not obvious what you will get, so maybe you should better check what you get at the end. You can see the size. So the size, remember, the first dimension in Matlab is the height, okay? So here the height is 576, and the width is 720 pixels, and you have, this time, 3 channels, so RGB. Okay, so same story, I can have a look at that. And this time I don't need to rescale anything because I'm working in Unit 8, so I should be able to see what's going on here. All right. Now the first thing I will do is to convert that again to double, okay? And for argument's sake, I'm going to keep the values that they are between 0 and 255. So now I just have to be careful not to do this because I will get everything right. What I want to do is to divide by 255 so the range is okay. Right, so we want to build a histogram of that. And now we've seen, so that's what you're going to see in the lab, if you're doing histograms really work on, the way it's specified in Matlab, they are really usually done on one value, okay? So you need to, pictures are 3 coordinates, okay? So colors is 3D, but Matlab won't do a 3D histogram for you like this. What we only do is like a 1D histogram. So you need to convert the picture into values of only 1 dimension. So let's do that. So we convert the picture from RGB to gray and see what you get. Sorry, probably should have done something like that. Right. So making sure that my picture is between 0 and 1 in floating point. And I'm going to convert that because this is a built-in function. Matlab expect the input to be between 0 and 1. And then I just rescale everything to 255 for argument's sake. All right, so now, all right, if I do this, I won't work because it's grayscale. So you just have to specify the grayscale image, and it doesn't work. What have I done? Where's peak? What am I doing? Oh yeah, no, sorry. Sorry, when you do a color map of gray, when you do this, you don't need to rescale between 0 and 1. All right, so just keep the values as they are between 0 and 255. Right. You will make these mistakes all the time. It's fine. Right, so this is your grayscale image. And remember what I said, like gray is, this is the intensity of your image. But remember what I said about the green being the kind of dominant color of, for intensity. I just want to show you what the green channel looks like. So the green channel is the entire picture in X and Y, if you want, so in Y and X, right? And the second channel, which is the green channel, okay? And so if you do this, then this is what you obtain. And I'm just going to flip back, put them side by side. So on the left, you have the official luminance, okay? And on the right here, you have, if you just extract the green channel, okay? You can see the difference is pretty slim, okay? So just to kind of get that for you, I mean, you can look at different channels, the red channels, for instance. It's interesting as well. The blue one, usually it's very noisy, and hopefully we'll see that here. If you zoom in on the green channel, maybe not on that picture, but usually the blue channel is less usable and it's a bit more noisy. Right, something we'll see later. Right, so just wanted to come to that point really, is we want to do a histogram, and in Matlab all the functions you can access to are, you have the help function, okay? And even if you define your own function, you can actually write easily a help by just adding some comments at the top of your function. I will do that in a different session here. So we have the function hist that we'll use in your lab. And if you do help hist, basically you have all this text showing up in your command window, and first is not recommended. But that's fine, we're still going to use it. Right, so hist bins the elements of y, so y is your input, into 10 equally spaced containers and returns the number of elements in each container. If y is a matrix, hist works down the columns. So this is a default behavior of hist, and just basically do a histogram and put everything into 10 bins. Split the range of your values into 10 different bins. It will just work out by itself. What we usually use it is by specifying what the bins are, okay? So where the center of these bins are. I'm just going to show you that, okay? So if you look at, we're going to try to have a histogram here, and we're going to look at the picture y, and we're going to look at all the values between 0 and 255, right? And if I just do this, okay, take your picture, put the range, and all working fine, except if you look at the variable, you see that what you got back is the matrix of size 256 by 720. All right? And obviously, this is not quite what you're looking for, okay? So this range of values, okay, coming back on that, this is us specifying, I want to know the frequencies of the number of elements that falls into for each of these integer values, okay? So I have 256 values I want to analyze in terms of frequency. So these are the 256 values I'm looking for. And this is the matrix I'm giving back as an input. Now, as said in the documentation for hist, hist will look at the dimension of that, okay? So if you give it a vector, it will indeed compute the histogram for that vector. If you give it a matrix, it will give you as many vectors as you have of columns. So in this case, the original picture is of size 576 by 720, so you have 720 different columns. So it will return for you a histogram for each of these columns. So H is this weird guy of 256 by 720. All right. So in your case, if you've just plot H, you will get this kind of weird stuff going on. Okay, plenty of colors, and basically you have 720 different graphs being overlaid on top of each other. All right. So that's not what you want. So what you want is to say, well, I don't care the disposition of or how y is structured. All I want is all the values of y. And so to do that, you go about doing this, okay? So this operation, which says transform my matrix in just one flat vector with all the values put back into it. And then you do this, then you're okay, you have your graph, all right? So there's this plot, there's different ways of doing this because the histogram is a very specific type of bar. very specific type of data, you can use bar charts, okay? And so you have the bar function that will actually do a solid line under what you want to have. Right. Coming back to that, you can change the bins, okay? And you can say, you know what, I want bins to take every, I don't know, let's say 8 pixel values, okay? So instead of trying to look at the frequencies of every single possible integer values that this y might take, I'm going to look at, you know, all the values between 0 and 8 and between 9 and 16 and so on, okay? And if you do this, then basically you get more coarse view of your histogram, and you have something like that, okay? Usually that's quite useful to have these kind of things because as mentioned in the course on histogram, if you do any kind of color transformation on your picture, you will have bins that will have values of 0. Okay, very quickly you have just some values. You know, if you apply any kind of transformation, look back in the coordinates in the slides, that will happen. Okay, some of the values might just be very big and next very small. Right, that's about it. We'll do 1 or 2 more sessions like that, so we can have all these little snippets of code handy for you to reuse in your labs, and when you get confused, you have that to come back to. Yeah, no, the last point, sorry, and that's the one, but we covered that. If you have your picture and you want to take the RGB, if you have the picture and you want to have the RGB histograms separately, that could be useful for you. The trick to use, well, the way I do that is I define each channel plane differently, okay? So I say, okay, picture of column 1 is actually all the red values, and that I assign that to a variable, and when you look at the variable, it just becomes a 2D array, and therefore I can do the same trick. I can say, find the histogram of R of the flattened value of that between 0 and 255, and then you can apply for it, okay? So that would be the histogram for the red. Unfortunately, in Matlab, you cannot just do something like this, okay? So ideally, you would like to say, if I do this, it just won't work, okay? So you can't contract all the values like this. You need to apply the function. So there's no simple shorthand for that. So the best way around that is just specify this intermediate variable and just use it for yourself. All right? That's it.